PPT presentation by Ginnela Someswara and Prasad. Subject HTLD. We main title of this PPT is Basic Universal Logic Gates in Digital Electronics. Yeah, let's go. Topics covered: NOT, NOR, and Universal Logic. Universal Logic are NAND, NOR. Introduction. What are logic gates? We use it in logic gates in so many applications in digital electronics and beyond in so many applications. We use that in so many applications. So learning this must is the basic fundamental in this digital electronics. Introduction. Yeah. Introduction about logic gate. Logic gates are perform binary operations, the 0 or 1. Yeah, 0 or 1. The binary system recap. For example, 0 is equal to low or off, 1 is equal to high or on. That's it. So we use that 0 or 1 in so many digital electronics. In analog electronics, the continuous this thing, but in digital electronics, the 0 1 is there. Why logic operations? Basic of all circuits. Yeah, this is basic about all digital circuits. We can build in that digital circuits in any circuit. We can build it basic and universal gates, and every CPU, memory, microcontroller is built using logic gates. Yeah, in every CPU logic gates and are there. In memory, the memory are NAND flash, that so many memory things are now there. The memories are built with NAND or NOR flash. That's we can learn about in deep in upcoming days. Means in final year or in any going in core. Microcontrollers in inbuilt using logic gates. Yeah, in microcontroller the gates are inbuilt, means there are inbuilt in that microcontroller applications. Yeah, this is applications for example simple door sensor, alarm systems, etc, etc. Not gate. Yeah, we go about basic logic gates. So the basic logic gates are not, or, and. 3 are basic logic gates. Symbol. We see that in that image the symbol is there. If you give A, the output is A bar or Q bar. In that image, if you give 0, the output is 1. If you give 1, the output is 1. Not 1, that 0. Yeah, that's a small mistake in that image. So if you give 1, the output is 0. That's it. In truth table we observe, if you give 0, the output is 1, means complement of input. If you give 1, the output is 0. Examples: light bulb controlled by NOT switch. Yeah, if you use in build that light bulb controlled by NOT switch, the input is 1, the bulb is off. Application: signal inversion control logic. In signal inversion, if you give a sine wave, means a positive and negative, the output is negative and positive, means the NOT gate acts as signal inversion. That's it. OR gate. OR gate, the symbol, if you see OR gate symbol, there is a curved shape in that OR gate. In truth table we see that if we give 0, 0, the output is 0. If you give 0, 1, the output is 1. Means the 0 is adding to 1, so output is 1. If you give 1, 0, the output is 1. If you give 1 comma 1, the output is 1. Means the input is added with another input. The output is A plus B. It is a Boolean expression. In that truth table you can see that. Applications in alarm systems, in etc. If we glow a bulb or glow a lamp, switching a R switch and B input, both are on NBR, the output is on. And if we give any input A or B, the bulb is on. Here let's see this example. So that's it. AND gate. AND gate is a basic gate. It is a multiplication with two inputs symbol. Y is equal to A into B. Means the input is multiplied with another input. 0, 0. The output is 0. If you give 0, 1, the output is 0. If you give 1 comma 0, or means 1 input A 1, output 0 when input is 0, means these are multiplication. 1 into 1 is 1. So if you observe any input that multiplies 0, the output is 0. So if you see 1 into 1, the output is 1. So AND gate is only high when both inputs are high. So for example, again in OR gate, if any input is high, the output is high. So we stop that basic gates. We can go in universal gates. What are universal gates? Yeah, universal gates. AND NOR are called universal gates. Any logic function means AND, OR, NOT, XOR, or these are built with universal gates with both NAND or only NOR. We can use that. It's simplify the circuit. Means if you simplify this with NAND or NOR, we can make if we have NAND and NOR, we can build any logic gate. So these are called universal gates. Let's go. Universal gates. Universal gates have two types: NAND, NOR. Already said that symbol and Boolean expression. Y is equal to A into B whole complement. Means this is coming with A into B whole complement. We can build with AND and OR gate, also truth table. If you see truth table, the output is 0, 0. The output is 0 only when input is 1. That's it. Truth table. We observe that truth table, when both inputs are high, the output is 0 in that NAND gate. If any input is low or both are low or any input high, the output is 1. Applications: the building all gates from NAND gate. We can use that NAND gate as a universal gate. You see that a small bubble in the symbol NAND gate. NAND gate is built with AND and NOT. So the AND gate, the bubble is NOT, means the input is inverse or complement. So NAND gate is a Boolean expression of y is equal to a into b whole complement. So let's go to NOR gate. NOR gate have a symbol like same OR gate. We see that a bubble in that end at output. So you observe that NOR gate can be built with OR gate with and NOT gate. So we can see the truth table. Yeah, if you give both are low, the output is high. If you give any input are high or both inputs are high, the output is 0. For example, only when no signal is given, output is 1. So if you not give any input, the output is 1. NOT gate applications, memory cells we can use in memories and control circuits and so many things. Real world applications of these gates, NOT gate. We use in inverters, data processing and etc. Inverter. How that inverts? Means the we already discussed the NOT is a inverts the output. Output is inverse of input. That's it. OR gate. All R systems we can build with OR gate logic a circuit, and that's it. AND gate. Industrial safety, access control, etc. AND gate we can use. NAND and NOR gate. Used inside microchips are universal building blocks. Means universal building blocks. We can build any gate from this. That's it. Thank you for giving this opportunity. Signing off. Bye bye.